one of the Marymount Algebra 1 placement test review. There are, how many questions? I think there are 180 questions on this placement. No, 190, sorry. 190 questions. So I'm going to try to do it in the least amount of time, as fast as I can, with still providing education and the ability for you to get things and understand things. So in these first 4 problems, we have orders of operations. So we're always going to look at the order or the operations and then place them in order of grouping symbols. Notice it's G, not P. Grouping symbols, exponents, multiplication, division, addition, subtraction. Multiplication, division, we're going to do it left to right, whichever one comes first, left. So we have -6 divided by 6. So -6 divided by 6 is -1. We have 2 minus 1, which is 1. We have grouping symbols, so we're going to do inside. So that's 6 minus, what's 4 minus 2 is 2, and that provides us 4. Orders of operations, we need to know that double signs is a form of multiplication. And so we have 1 plus 8 minus 12 over -3. We'll do 12 divided by -3, which is going to give us -4. And then we have double signs again. So we have 1 plus 8 plus 4, 9 plus 4, and 13. We are going to do the division. So we have 9 minus 24 divided by 8 is -3. We can do the double, well, let's do -5. We're going to do the double signs here, the double signs here. 9 plus 3 plus 5, which gives us 12 plus 5, or 17. That's nice and done. Now we're going to substitute values. So we have -5 times x squared, my x value. So because negative is included with the x for the value of x, we're going to write quantity minus my x value plus my y value, which is 5. We're going to do grouping symbols first before exponents. -5 times quantity -2 squared minus -2 plus 5 is 3. We'll do the exponent. -2 squared is -2 times -2, which is 4, minus 3. That quantity isn't doing anything. We're going to do the multiplication, which is -20. Multiplication before addition and subtraction, and that gives us -23. We have the absolute value, which is a form of a grouping symbol, but we'll get there. Then a quantity, n is -9 over 3 minus 2. So we will do this grouping symbol first, which is 5. The absolute value of -5 just wants the distance of a number. A number has 2 things. It has distance and direction. The direction is the positive and negative. The distance would be the number, I guess. Yeah, we can see it like that. This is going to be a product. -9/3, we're going to do the division, which is -3 minus 2. We will still do inside the grouping symbol, which is -5. And we get -25 as our answer. Solve each proportion. We can't get to these V's because those are grouping symbols. So we use the technique of cross product. We know that all fractions have an equivalent cross product. The trick to this is the negative. That little negative there has to be in either the numerator or denominator, and it needs to be in one of them, not both of them. So let's put it up in the numerator. So if we have 7 times v minus 3, that's the green part, will equal the cross product of -12 times v plus 5. It doesn't matter where the negative goes, you just have to decide on it. So we put it up in the numerator. we get we're going to use the distributive property for both of those sides. We're going to simplify the left side, simplify the right side. And now we're going to move variables to one side and constants to the other. I'm going to move my variables to the left side, and I can do the constants in the same line. That's going to give us, nice try, Mr. Mac. That's going to give us 19v equals, that's 39? How come that doesn't feel right? I think that might be right, though. Oh, ugly, come on. Really? I feel like I'm making a mistake. Negative 39, I did make a mistake. Divide by 19, divide by 19. V equals negative 39/19, which should be the answer. I would absolutely leave it as a fraction. I sure as heck wouldn't round it. Negative 2.05. Come on. That would be an approximate value. Why are you giving an approximate? Solve. That is the answer. This, negative 2.05, is wrong. That is not even, that's an approximate value. Boo on you. Just leave it as a fraction. Why give me that value where you have to round? Did it say to round in it? No. This is the only answer. High school and college will not accept approximate answers. You're not rounding. Give an exact answer. Improper fractions, nothing wrong with that. Don't like that. I'm not happy with that. I don't agree with that at all. Cross product again. You have 11 times b plus 1 equals 6 times b minus 1. 11b plus 11 equals 6b minus 6. Let's move the variables to the left side to keep them positive. Move the constants to the right side. We get 5b equals negative 17. Another ugly answer. Come on. Divide by 5, divide by 5. B equals negative 17. 17/5 should be a suitable answer. Now, 17 divided by 5 at least gives you a terminating decimal. And so we could say, okay, or, what was that, negative 3.5? No, 3.4. Negative 3.4 is okay, or negative 3 2/5 is an okay answer. These are acceptable. This is wrong. That's not an exact value. That is an approximate value. That's why it's wrong. If you want to give me negative 2 and what's that? 2 1/19. That's okay. That's an acceptable answer. Those are equivalent. This is not equivalent. Not equivalent. Sorry. I know we're trying to work on efficiency and speed on this one, so this video isn't 2 hours long, but that's important for you to know and comprehend, so I'm willing to take the time. So find each percentage of change, state if it's an increase or decrease. So we have our original to our new, and we know that step 1 is always find the amount of change, and the amount of change is new minus original. So 15 minus 12 gives us 3. So my amount of change is going to be 3. Step 2 is find the percentage of change, which is the amount of change divided by the original. Very important part right there. So we have our percentage of change for this problem is 3 over the original, which is 12. Now, that is a fractional value, so we can change that fraction to a decimal, which is 0.25, and then we can change that decimal to a percent by moving it 2 places. So we get 25%, and we must include increase. Why is it increase? Because it's a positive value. So the correct answer would be 25% increase. Let's go to problem number 2. We're going to do the same thing. This is our original. We start with 16.6 and then we move to 13. So amount of change is going to be new minus original. So our amount of change is going to be negative 3.6. And then we take our percentage of change, which is going to be our amount of change divided by our original, 16.6. Now, I can convert this to a decimal by doing 3.6 divided by 16.6. And that will give you that ugly number, which is really unfortunate. Because again, in the directions, it doesn't say round. What am I supposed to round to? Am I supposed to round to the tenths, whole number, hundredths, thousandths? So I don't like that. That's not really very fair. But we're going to say 21. So that percentage of change as a decimal is 0.2168, blah, blah, blah. If we move it 2 decimal places, that's 21.68% decrease. So I'm going to round it to 21.7% decrease is relatively reasonable. What do they say in there? 21.7 degrees. Yeah. So I don't like that. This is approximate value. We hate approximate values. We hate rounding in math. Original, new. So we're just going to do the same thing each time. Step 1 is 35 minus 99, which is going to give us an amount of change of, what's that, 64? So percentage of change is going to equal our amount of change over our original. That's going to give us a repeating decimal of 0.64, 6464. I think. Let's see if Mr. Mac is correct. 646464. Mr. Mac knows his repeating decimals. 0.64 repeating. So if we move that decimal 2 places, so 1, 2, and if we're going to do this again, and we're going to round to the tenths place, that would be this. And are we increasing? We went from 99 to 35, so it's decreasing. The other reason is, oh, that was negative 64, negative. I don't think I did that on the other decreasing, sorry. Yeah, that's negative. Yeah, so that decimal is actually negative. That's, oh, well, we don't, it's decimal, and then we replace the negative with the word decreasing. So that's how we do it. Yes, you include the negative in its decimal form until we change it to a percent. You can't have negative percentages. This is our original. This is our new. So that's going to be new, 74 minus 17, which gives us amount of change that equals 757, positive 57. So our percent of change is going to equal 57 over our original 17. That's a big percentage of change. We again will use our calculator. It'll be interesting to see if they let you use calculators at Marymount, because if they don't, you're going to do some crazy 3.3529. 3.3529. We'll move that decimal 2 places. So we get 335.3% increase. So we again rounded to the tenths place. Don't round until you move the decimal point. That's the important thing, is to round later than earlier, or else you'll get more. Really? You're going to have 6% of change problems? I mean, that's a little overdoing it. Original, new, so we have 395 minus 305, which is 90 over 305. What are we going to produce? 90 over 305. What's the difference between the, I mean, I don't know what they're trying to prove here. 29508. 29508, I guess moving it and seeing how we're going to round. Percent increase. Maybe that's what they're trying to see. Can you round properly? 29.5 increase. That's original, new, and that's going to be 292 minus 309, which is going to give us a negative 17. So that's our amount of change. So we're going to have negative 17 over 309. 17 divided by 309. 309. 50. Ooh, okay, that's a fun one. I get this one. 0.0550. 0.055016. So if we move it 2 places, this is good. I like this question because it's going to be 5.5, right? Move it, that's 5.5. And then we round to this place and we look here and that tells us so. That's going to be percent, and that was negative, so decrease. 5.5% decrease. Yeah, all right. I always like, there's a number of different ways that this can be taught. I always love the is over of equals percent over 100. We have the part over the whole should always be equal to the part over the whole of the other relationship. So we know that 100% would be the whole, and then the percent would be the part, and then of 66. So of is the whole. So if we fill in this is of, so let's take a peek here. What is, so my unknown is going to be there. 42% is going to go into the percent. Of 66 is going to go there. And then we always have 100 always goes into our template. So we're going to fill in this template. So the yellow is the unknown. 42 is going to go up here, and of 66. And then we're going to do just cross product. Or we can multiply by 66. I don't know if any of you see that. It's a word problem. This x is being divided by 66. So if we just multiply both sides by 66, and then we can reduce that. So that becomes 33. This becomes 50. We can reduce that. That's 21. That's 25. And we get x equals, can we reduce it anymore? No. 21 times 33 over 25, which is, I don't know what that number is. 21 times 33 equals, divided by 25, gives us 27.72. 27.72. Now, again, I mean, what was, let's do this, 21 times 33, 693. 693 over 25, and I don't think that gets reduced by any number. It doesn't go into 5. So you're going to have that, or you're going to have 27 and what's 25 times 27? 25 times 27, 675 minus 693, 693, 18. So 18/25. That's an acceptable. This is acceptable. It's just there's a lot of decimal work. There's a lot of division here that is not just mental math or simple. It's very time consuming. So that's a concern. If they're not going to give you a calculator, I feel that it's very unfair to make you do these huge numbers and expect you to write it as a decimal in the answer key for this problem. It is 27. Whoa, they rounded that? All right, I don't agree with that. On the answer key, it says 27.7. Where are the directions to round to the 10th? Question mark, question mark. I'm looking at the beginning of the test. Does not say anything about rounding. So I disagree with the answer key there. This is okay. I shouldn't do it in red. I should do it in green because it's okay. This is okay. This is okay. This is okay. That I don't agree with. But you know me, Mr. Mac. Is over of equals percent over 100. So what is? So is question of 1.8 equals 98% over 100. We can cross product or we can multiply. I'll show you the cross product way because I would multiply both sides by 1.8, but the cross product is just this, much like we did earlier in this video. So you have 100 times x equals 1.8 times 98. You have 100x equals 98 times 1.8, 176.4. Divide by 100, divide by 100. This is something you should know. Dividing by 100 moves the decimal point 2 places, so 1.764. That should be the only answer they give you, but I'm sure that the book does 1.8, or your answer key, I bet says 1.8. What does it? No, it says 1.76. Okay, right now we're rounding to hundredths. Why? That makes no sense. Not happy with you, Marymount. 98% of 74 is what is still x of 74. 98% over 100. So we'll multiply both sides by 74. And that gives us x equals, that is going to be 37 over 50. 50 can be reduced to 25. That's going to be 49. Nope. So you have 49 times 37 over 25. Those are at least manageable, more manageable. 49 times 37 equals 1813 over 25, which would be a acceptable answer divided by 25 gives you 7252. Moving into the other problem, 7252, I think I said 52, which is the other acceptable answer. We can do 72 and however many 25ths. I'm sure that they have 72.5. Do they have 72.5? Yes, they do. Of course they do. Makes no sense. I know. I'll stop. So 41% of what is now 35 is over of is this time what we're looking for. 41% over 100. We get 41x equals 35 times 100. My variable is in the denominator. That's why I'm going to choose the cross product, because isolating it's going to be a little bit more challenging. So just do cross product. Divide by 41, divide by 41. None of those go into it. So we get 3,500 over 41, which should be an acceptable answer, or 3,500 divided by 41. Come on. Which is 3658.5. X equals 85, 3680, no, 58.5. 58.5. 3658.5, 3658.5. So that is a repeating decimal. That should be the only answer. Well, actually, That would be okay. That would be okay. I'm sure that they give the answer of 85.4. 85.4. Nice. More is of or of. Okay. There's my 330 of equals percent over 100. So we have 330 times 100 equals 300 times x. We're going to divide by 300, divide by 300. Those zeros cancel, those zeros cancel. This 3 can cancel into here, which is 110. So it equals 110. No calculator needed. Right, 110, 19, 110. That was way too easy. Is over of equals 13% of 100. So notice that's the part and the whole. We continue to go back to that part and whole part. We're going to use cross product again, 13x. We'll divide by 13, divide by 13. 13 goes into 120 or 260. It's going to go in 20 times, so it's 2,000 equals x. Also, no calculator needed for number 20. Those I don't mind. Those are good. Those are great questions. Now we're going to solve. Let's simplify. We end up with x. Let's simplify first. Combine like terms. Minus. Now we're going to isolate. Get rid of the things being added and subtracted first. Then we're going to divide, and we get 3 equals n. If you have the time, plug it back in and check your solution if you want. We're going to, well, we could divide by 2. That would be the high school way, but we'll do distribution first. That gives us negative 4m minus 14 equals negative 28 minus 6m. Let's move the variables to one side. I like my variables being positive, so I'll move them to the left side. We can move the constants to the other side. That's 2m equals negative 14 divided by 2, divide by 2, m equals negative 7. I'll show you how you could, if you wanted to, let's take this problem. I know this is taking time, but for efficiency purposes, let's rewrite this problem. Let's show how we could do this. I could divide each side by negative 2, which is, and then that gives me 7, no, that's a 2 actually, sorry. It's a bad 2, hence why I almost wrote it wrong. Which would give me, these cancel, so that's 2m plus 7 equals, that's going to be 14 plus 3m, and then we can subtract the m, subtract the 14, subtract the 2m, subtract the 14, we get negative 7 equals m. Same answer, just a little bit more efficient. This you can't do. This you are going to have to distribute because you have to combine variables, and you got to simplify the right side. So you're going to get 25 plus r equals negative 10 minus 40r plus 6r. We can't combine those r's until the parentheses are gone. 25 plus r equals negative 10 minus 34r. Let's move the r's over. Move the r's over. Let's move the constants over. And we get 35r equals negative 35. Divide by 35, divide by 35. We get r equals negative 1. So 24, 7, negative 1. They use solution sets. You should be very comfortable with solution sets. We know that. Again, there's no... What?
Good afternoon, everybody. Just a reminder of the presentation from Mutual America about the 403B investment opportunity was going to start at 1:15 in the music side of the school hall. Thanks.
There you go. Make sure that you invest in your retirement, kids. Save now, create a savings account, and find ways for it to grow. But to start investing now, that what we call compound interest is so good. That's called exponential growth, kids. Start investing now. So there's no shortcuts here. We are going to have to do the heavy lifting of distributing, simplifying each of the sides, and then moving. So negative 6n, that is going to be plus 132n minus, that is going to be 96 equals negative 10n plus 40. Let's simplify the left side. We get 26n minus 96 equals negative 10n plus 40. Let's move the variables to the left side. Let's move the constants to the right side. That gives us 136n equals 136. Oh, look at you. N equals 1. So 25. My feet. Again today. Negative. Where did I forget the negative? Where did I forget the negative? It says the answer is negative, and they're typically correct. So where did Mr. Mac make his mistake? Where did I make my mistake? That's positive, that's negative, that's negative, that's positive. I'm going to move my, that's positive 132. 25. Did I look at the wrong problem? 20, no, it's positive 1, Mr. Mac. You were correct, but it's okay to check. If I still couldn't find it, I would plug it back in and check and make sure that it made a true equation. Negative 28x plus 6 equals negative 3 minus 21x minus 7x. Negative 28x plus 6. We're always going to simplify sides. Minus 3 minus 28x. Oh, look at you. We're going to move the variables first. This example is why we move variables first. We get 6 equals negative 3. That's a false statement. So the answer is no solution. There's no solution because my variables canceled out and my constants were not, did not make a true statement. Absolute value. Always remember, isolate. That's not how to isolate. Isolate absolute values first. Make sure it's isolated. We have the absolute value. And think about it. If we covered this up, if this was a question mark, what value could this inside be? It could be 6. Absolute value of 6 produces 6. And the absolute value of negative 6 could equal that question mark. So technically, you have question mark can equal 6, or that question mark can equal negative 6, because both of them would produce a absolute, would give you an absolute. So we're going to replace that with what was inside there. So that's why we write two statements. That's why we write it twice. That's why we write it with a positive 6 and a negative 6. That's the reasoning and the logic behind it. Don't know if you ever knew that. That's an important thing. Divide by negative 6, and we get n equals 1. So my answer is negative 1, 1. We can write that in a solution set. And in high school, you'll see a student that will write plus or minus 1. Be interesting to see what they do. They do negative 1, 1. Of course they do. Same thing. My absolute variable is isolated, which is great. So I will take what's inside. I will set it equal to the positive value and the negative value of it, of this. It's not making this. I'm not making this negative. I'm just saying, hey, negative values will pop out as positive values. So divide by 5, x equals 6. Divide by 5, x equals negative 6. And we get negative 6, 6 as my solution for number 12. 28. Same thing, it's isolated, so that's good. Negative 7 minus 8k equals 73. Negative 7 minus 8k equals negative 73. We're going to now just solve. It's a two-step equation. Very easy. Whoa, almost made it an x. K equals negative 10. That's one solution. Add 7, negative 8k equals negative 66. Negative 8, negative 8, right? 6, 12, 13, yep. K equals positive 33 over 4. That would be an acceptable answer in my book. You could also have K can equal 8 1/4, and I'm sure the book says 8.25. Let's see what your answer key on 29. Oh, 33 over 4. So, yeah, I would put them in numerical order. That's the inconsistency of this. What? Now you're giving me fractions. Now you're okay with fractions. Okay, who cares? Let's create two statements. It's isolated, so we get 10a minus 8 equals 78. We get 10a minus 8 equals negative 78. Add 8, add 8. 10a equals 86, divide by 10, divide by 10. A equals 43/5. Let's add 8, add 8. We get 10a equals negative 70. Divide by 10. We get a equals negative 7. I'm going to put my solutions in numerical order. Negative 7 and 43/5 are my two solutions. Yeah, they don't put them in numerical order. Not isolated. So we have to divide by negative 6. We get the absolute value of 3 minus 9x equals positive 3. Now it's isolated. Now we can separate them into two statements. Minus 3, negative 9x equals 0. Divide by negative 9, x equals 0. Minus 3, negative 9x equals negative 6. Divide by negative 9. We get x equals 2/3. So my solution is 0 2/3. Watch, they write it as a decimal. Nope, 0 2/3. And it's numerical order. Good for you, book. Minus 4. Absolute value of 9x minus 9 equals 72. Make two statements. 9x minus 9 equals 72. 9x minus 9 equals negative 72. We're going to add 9. 9x equals 81. Divide by 9. X equals 9. Add 9. 9x equals negative 63. Divide by 9, x equals negative 7. Look how fast we can do that. Negative 7, 9 are my two solutions. Yeah, you should be impressed with that. That's what you should be shooting for. Solve each equation. Remember to check for extraneous solutions. So that means we're going to have to plug values back in. So I have my variable in a radical. I can't get it out of that radical. I have to think of inverse operations. How can I get rid of a square root? Is if I square both sides. I don't have to do plus or minus because I'm not taking the square root of a variable being squared. I'm squaring, a little bit different. So we get 4 equals m over 4. These cancel. The square and the square root will cancel, leaving me with my m over 4. Let's multiply both sides by 4. That gives us 16 equals m. If I plug 16 in there, it's not going to give me 0. I'm not taking the square root of a negative number, so it's fine. It's just 16. We have to be aware of the situations like I just said. Is 0 in the denominator? Am I taking the square root of a negative number? Those are those extraneous, or it just doesn't work, right? So we're going to square both sides. We get 1 equals n plus 5 minus 5 minus 5. Negative 4 equals n. Now, if we plug in negative 4, that's going to give me the square root of 1, so that's fine. That's an acceptable answer. Let's square square. You get x squared equals 20 minus x. Let's move set equal to 0. We're going to add x, minus 20, minus 20. That gives us x squared plus x minus 20 equals 0. I know what you're asking, Mr. Mack. How did you know that you had to set it equal to 0? Well, we have two variables, and they're at different exponents. So it's factoring. We set it equal to 0, and the only way we can turn this, we're going to use the 0 property. And 0 property is when we can turn them into binomials. You can use the quadratic formula. I wouldn't. I already see a times c, and I see that it's going to be x plus 5, x minus 4 equals 0. So I know that my a times c, 1 times negative 20, I don't have to do all this stuff. I already know because I've done so many, and I can see that the signs are going to be different. The bigger is positive. And then I know the 0 property, so I know that I'm going to set each one equal to 0. I don't even have to do this part. I can just look at that and see that the answer is going to be 4 and negative 5. We get x equals negative 5, x equals 4. Those are the two values that would make these 0. How do we know it was 0? Because the only way you can multiply two numbers and get 0 is if one of those two are 0. Negative 5 and 4. I'm going to look for extraneous. Negative 5 makes 25. That's okay. Ooh, no. Negative 5 is going to be extraneous. Let me show you. Good problem. Copy. Let's slow it down a little bit now. Let's see what's going on here. Oh, let's see what's going on here. That was dumb. So I have my two solutions, negative 5 and negative 4. So if I plug in negative 5 equals square root of 20 minus negative 5, negative 5 equals the square root of 20 plus 5. Negative 5 equals the square root of 25. Does negative 5 equal 5? No. So this is an example of an extraneous solution. Let's try 4. Does 4 equal the square root of 20 minus 4? Does 4 equal the square root of 16? Does 4 equal 4? Yes, that's why 4 works, and the other one doesn't. Good, so here we go. We got to be careful. We're going to square both sides. We get p squared equals 10 minus 9p. Let's move things. Why am I moving it to the left? Because I want my first term to be positive. I want my first term p squared to be positive. And now, can we factor that? Can you mentally factor? Can you know that it's going to be p plus 10, p minus 1? Signs are different, bigger is positive. And do you know that the solutions are negative 10 and 1 because you set them equal? And now you got to check for extraneous, negative 10. So if I plug in negative 10 there, that wouldn't work because we get negative 10 equals the square root of 100, and negative 10 does not equal 10. So negative 10 is extraneous. My only answer is 1. So be careful on the test tomorrow for that very specific reason. Let's isolate the radical because we're going to square it. So when we square, we're going to square the left side, we're going to square the right side. We have to look at that as a quantity. These cancel, so you're just left with what's inside the radical. This is a binomial square. you better know how to do a binomial square super fast. And now we're going to move it and set it equal to 0. That gives us 0 equals n squared plus 8n minus 9. Yes. So factor that. That becomes n plus 9, n minus 1. So my possible solutions are negative 9 and 1. Let's look and see. Ooh, all right. Well, we're going to have to copy it and do it out. Copy. I can't eyeball that one. That one's a little bit more challenging for me to eyeball it. So I'm going to take 2 seconds and I'm going to find which is the extraneous. Which one do you think the extraneous might be? Yeah, the negative. I would definitely test the negative. 2 times negative 9, which actually is okay because we're not going to get a negative value inside there. So that at least is somewhat pleasant. Yeah, all right, so that's actually going to be extraneous because 9 plus no number, this has to be a positive number coming out of there, and so it would never be negative 4. So we have 9 plus, that's going to be, what's that, 16? Yep, 9 plus 4 does not equal 5. 13 doesn't equal 5. So, yeah, that negative 9 is extraneous. Not all the time, but in these cases. And when we plug in 1, you get 36. 6 minus 1 is going to be 5. Yeah, so that eyeball quick is an okay check. Let's add b to both sides. Looks very similar to the problem we just did. Equals b minus 10. Let's square both of them. When we square, that's a quantity. That's 60 minus 6b equals b squared minus 20b plus 100 minus 60 plus 6b. Again, I'm still not using the quadratic formula. I can do this. I mean, these aren't crazy numbers. What's that? Well, now, as I just say, it's not crazy. 1 and 40, 2 and 20, 3, no, 4 and 10. Signs are the same, both negative. There they are. 0 equals b minus 4, b minus 10. So that gives me the solutions of 4 and 10. Let's check for extraneous. Yeah, okay, so that's going to be interesting how my left side equals a negative. Copy. So it'll be weird to see. Whoa, way too much. So let's paste. So let's plug in each of the values. So negative 4 plus square root of 60 minus 6 times 4 equals negative 10. That's negative 4 plus 60 minus 24, negative 4 plus, what's that, 36, negative 4 plus 6 does not equal negative 10. So 4 is the extraneous. 10 would work, negative 10, and then, yeah, that you get 0 coming out of that square root. So it's just 10. And we did it relatively fast. Now you're back to your comfortable. We have like base, I don't want red. We have like bases being multiplied. We have that coefficient, then we have n times n to the third times n. So when we have like bases and we're multiplying, we add their exponents. So we get 2n to the fifth. We're going to go a little bit faster. K times k squared, like bases, k to the 1 plus 2, or k to the third. Coefficients, 2 and 1, which is 2. A to the 2 plus 0 gives you 2a squared. Coefficients, 2 times 3 is 6, times x to the 3 plus 1. I think somebody's calling me. They are calling me. Scott Clark, lacrosse, hello. That's very interesting. 6x to the 4th, wow. What does Mr. Clark have to say? I can't wait to hear that. Voice message. That's an old 8 years ago. Lacrosse dad. Orders of operations. So we can cut to the chase here. It doesn't matter what's in there. We're going to simplify all this stuff inside the grouping symbols, and then we're going to take that to the 0 degree. It doesn't matter if it's negative, positive, because the grouping symbols, that's going to end up being 1. So don't waste your time with that problem. Do not. You better be efficient. So here we're going to distribute. You can distribute exponents across multiplication. So that's the quantity of -2 squared. U to the -2 times 2. V to the 2 times 2. When you have a power of a power, you multiply V to the -5th. So we're going to simplify that. Oh, they're doing the voicemail. Adam. No, my name is not Adam. That's very interesting. Maybe somebody stole his phone. -2 quantity squared is that U to the -4th, V to the 4th times -2V to the -5. Let's do coefficients. That's -8. This doesn't have a like variable. This does, and we are multiplying. So we are going to add those exponents. -8, U to the -4th, V to the -1. It says only positive exponents. So we are going to, wow, still leaving me a voice message. When we want to get rid of those negative exponents, when we change the sign, we're going to change the location of the base. It's in the numerator, so we're going to move it down. The coefficient is going to stay up in the numerator. U becomes U to the 4th. V just becomes V. We would never write it as V to the 1st. Scott Clark, yeah. Hi, Rob. You are, what's that? Hi, your appointment, April 26th. Is today April 26th? No. Okay, that's next week. My doctor's appointment. Sorry, I'm just checking. It's just very, very strange that this person would call me. Yeah, I think it's a butt dial. That's a long butt dial. Very interesting. Thanks for staying here. We're still working. We're going to simplify that exponent first by distributing. You get 2U to the 0. If you want to make that 1, go for it. That's going to be efficient. V to the 5th. That's 2 to the 3rd. U to the 5 times 3. V to the 3 times 3. 2 times V to the 5th. We can multiply those. 2 to the 3rd is going to be 8. You should know that. U to the 15th. V to the 9th. We're going to do coefficients. 16. U to the 15th. Let's do like bases. V to the 5 plus 9. 16. U to the 15. V to the 14th. I saw what you did there. I see what you did, you little sneaker. 45. Oh, it should be in alphabetical order. They don't put it in alphabetical order. Again, boo. Take the time. If you're going to make this placement test, come on. -1. We'll just put -1 just so you know that there's a -1 there. That's going to be 2 squared. Y to the 1 times 2. We'll do that also. X to the 2 times 2. -1 times X times Y to the 5th times 4 times Y to the 2nd times X to the 4th. Let's do coefficients. -4. Let's do like bases. X to the 1 plus 4. And let's do our y's. Y to the 5 plus 2. We're adding because we're multiplying like bases. -4, X to the 5th, Y to the 7th. I'm surprised I didn't make that the 6th. Number 46. Yup, good. We got to distribute before we do anything else. That's going to be the quantity of -2 to the 3rd. You should write it notation properly. If you don't have those parentheses around there, that is technically an incorrect notation. We can simplify the denominator. We have coefficients. That's going to be 4. We have to the negative 2, and then we have this. This is y to the negative 2 plus 2. So this is going to be negative 2 times itself 3 times, which is negative 8, x to the 12th, y to the 6th, over 4, x to the negative 2, y to the 0, which is 1, technically. So we're going to deal with the coefficients again. These are going to be dealt with differently from like bases and like bases. That is dividing. So negative 8 over 4 is negative 2, x to the 12 minus negative 2, y to the 6 minus 0, negative 2, x to the 14th, y to the 6th is our answer. That's a good one. That's just good for technicalities and all the little nuances that come with simplifying with exponents. I'm going to, because it would be very difficult, if you wanted to get rid of that exponent first, you would have to distribute it to every single thing inside there, including the 2, including the negative. So that to me is, and that negative, oh, I would have forgotten that negative. So I'm going to simplify this denominator. I'm going to send this negative up there. So we have negative v u to the 3rd over, I'm going to simplify the denominator, that's negative 2. We have coefficients. We have u to the 4th plus 4. We have v to the negative 3 plus negative 4, all being cubed. So keeping track, and I'm going to u to the 3rd v. I'm going to go alphabetical order. That is negative 2 u to the 8th, v to the negative 7 cubed. Keep that separated. I'm going to do coefficients, negative over a negative, and we're going to do u to the 3 minus 8, because we're dividing, v to the 1 minus negative 7, all over 2. The 2 negatives canceled, but I'm going to keep that 2 in the denominator. And then that's all cubed. U to the negative 5, v to the 8th over 2 to the 3rd. I'm going to move that negative exponent. You don't have to, but v to the 8th over 2u to the 5th over 3. Now I'm going to distribute. So you have v to the 8 times 3, 2 to the 3rd, u to the 5 times 3, which gives you v to the 24 over 8u to the 15. Oh, wouldn't that be nice if that is the answer? 48. 48, v to the 24th over 8u to the 15th. Would you? Let's go. Yeah, this is going to be tricky. So let's deal with the numerator. We're going to deal with everything in the numerator. And then we're going to deal with this in the denominator. So let's deal a to the negative 4 plus 1, because we're multiplying like bases, b to the negative 1 plus 2 over. Now let's look at this as negative 1a to the negative 4. Oh, that's, You want to know how I'm going to deal with that? I'm going to deal with that, but I wanted you to see that. That's important. We're going to deal with that negative first. And then we're going to move that negative a to the 4th. So everything is going to be in the numerator. That gives us a to the negative 3, b to the 1st, and this is negative 1 times a to the 4th. So when we distribute it, that is a to the negative 3, b, that's going to be the quantity of negative 1 to the 4th, a to the 4th. And now we have our coefficient, negative 1 to the 4th, is going to be positive 1. We have our like bases, a to the negative 3 plus 4, b, and that is just going to be ab. Oh, look at you. Nice, clean number 49. ab. And they say ba. So bad. Well, let's deal with y to the 0. So you have x squared. Let's put that negative up there. We have to do this exponent. I'm going to move that up. 2x to the second to the first, which anything to the first is just what that is. That's 2x to the negative 1y. So we have negative x squared times 2x squared over 2, let's move this x up. We're going to move that up, 2y. We have negative x to the 2 plus 1, and 2, this 2, so that's a negative 1. So that's going to be negative 2 over 2y, which those cancel to make negative negative x. We're going to combine that to make negative 1, x to the 5th over y. I like that. Did you get all that? Hopefully you got all that. Where's my negative x to the 5th over y? Yeah, that negative can go up in the numerator, it can go in the denominator, or it can go out outside of the fraction. Any of those is okay. That's how many more pages we have for this video. Okay. Name each polynomial. Remember I said we'll never need to know that. Well, Marymount wants to know it by degree and number of terms. So this is a 4th degree binomial. Since there are 2 terms, we can get specific. This is a 1st degree binomial. So those are quadratic, linear. That's not how, no, degree, that's not how you name them. That's not, you do degree, 1st degree. And yes, linear because it's going to produce a line. Quadratic, quartic, come on. 4th degree, 1st degree should be sufficient. So we have to distribute out this negative to all 3. I see way too many students only distributing it to the 1st term. You got to do all 3. And in the process, I'm going to put it in standard form so I can see my terms, sort of see where they're going to be sorry, ran out of space. And so 7n to the 4th minus 11n to the 4th minus 5n to the 3rd plus 8n to the 3rd minus 14 minus 7 gives us negative 4n to the 4th plus 3n to the 3rd minus 21 for number 53. Yes, and I like that they put in standard form. That's not going to affect anything, so we're just going to look for and we're going to try to put it in standard form. Those are so that's going to be 16x, and these are so that's going to be positive 7. So 16x to the 3rd plus 16x plus 7. Yeah, keep it simple. I'm going to go left to right. I'm going to do addition and subtraction. I'm going to add first. Then I'm going to subtract, and when I subtract, I'm going to remember to do that. Now, you could just align them all. There's so many, and while you're distributing it, we'll do that. We have 14x to the 1st is going to be my 1st term, and let's cross it out so we know. Then we're going to have plus x squared y squared. We're going to cross it out. We're going to have x's are going to come before. We have positive 13xy. Cross that out. We have a positive 4xy. Let's cross that out. It became positive because I distributed. Now we have y variables as our fronts, and that's negative 6y squared. Got that taken care of. Minus 3y squared. Sign doesn't change because it's a positive. And then we have plus 9y squared. Now everything is in order. 14x to the 4th. No partner, x squared, y squared. These have partners. That's going to be combining coefficients. 17xy. These all have the same, and those cancel. And so that would be my answer. 14x to the 4th plus x squared, y squared plus 17x xy is in standard form also. Same thing. I'm going to try to do this all in one fell swoop. A's are going to come before B's, and so I have negative 4a to the third b to the third. That's done. This is going to be positive 6a to the third b to the third. That's done. This is going to be positive 6a to the third b to the third. That's done. I changed the sign because of this negative and that negative. And now, what's my next a's? So that's going to be positive a. That's done. This is going to be negative 2a. That's done. And now I only have constants. So I have my 9 that is unaffected, and my 14, negative 14, which now becomes positive 14. Ooh, let's look at coefficients for all of those. That's going to be 8a cubed b cubed. These two is negative a. These two is plus 23. So number 56. 8a cubed b cubed minus a plus 23. All right. All right, we're going to do a little FOIL, first, outer, inner, last. Our firsts, our outer, our inner, our last. And these will be like terms, plus 4x minus 8. 57. This is such an enormous packet. Good. First, outer, inner, last. We can do it. Even doing first, inner, outer, last, that's still pretty fast to be able to get the right answer. So to me, that's just easier. Negative 35p squared plus 25p plus 56p minus 40. Negative 35p squared plus 81p minus 40. 59. Yep, that's good. Negative 8k squared plus 8k plus 24k minus 24. Negative 8k squared plus 32k minus 24 for 60. Yep, good. All right, now we just distribute 3 times. So we can't do first, outer, inner, last. We just have to do double distribution of each of these from the first binomial. So 24n squared, n cubed plus 12n squared plus 32n. And watch this. Minus 36n squared minus 18n minus 48. You see how I did that? I don't know if you see that. That's pretty good. 24n cubed minus 24n squared plus, what's that? 14n minus 48. That's a horrible 48. 48. 61, 24n cubed minus 24n squared plus 14n minus 48. Let's go. Minus 6x to the third minus 8x squared minus 8x minus 18x squared minus 24x minus 24. Negative 6x cubed minus 8 and 8, 16, 26x squared minus 32x minus 24. 62, where are you, 62? Yes, 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 yes. All right, we're getting there. This is a binomial square. You can either do this and do it really quick, or you can look at that as this and do it slower. My advice is you do it faster. R squared, you're going to multiply these two and then double. So 2r, and then you're going to square and square. So that's the easiest way to do those. These are conjugates. Remember what happens with conjugates. Our outside and inside are going to cancel. So we're just going to multiply our firsts and our lasts. N squared minus 36. All right, that's 64. This is a binomial square. We're going to multiply these, which is negative 48x, and double it, which is 96x plus 36x squared. We're going to square. That's how I got to 64. We're going to square. That's how I get this. I'm going to rewrite it as 36x squared minus 96x plus 64 because I'm a stickler for standard form. They clearly are not. You could also write that as, you can write that out as 8 minus 6x, 8 minus 6x, because that's a binomial square. Super slow. This is not long division. Some students think that this is long division. This is not. This problem, I was excited to explain this problem, is just that. And we should be very comfortable with that. We know that it's going to be separated under each of the terms. So it's actually really simple problem. And then we deal with coefficients. We deal with the coefficients, 10, then we deal with the like variables. V to the fourth over V, they cancel. So you're left with V third plus 3V squared plus 1/5 V. That's how I would write it. It would be interesting. Let's see what they say for 67. All right, I even like V over 5. That's nice. That's really good. That's some good advanced stuff. But we can get this really quickly. And remember, we have quantity. And if that was multiplication, we would distribute. But it's not multiplication, it's division. So you're just distributing the division to each of these terms. It's no different. So that is how you can think about it. 3b squared plus 1/3 b plus 1/2. Yeah, that's how fast. You should be able to reduce fractions that fast in 8th grade if you want to be in advanced math. That's it. That's our first video. We just did problems 1 through 68. Nice. Now, next video will be some factoring. So, good luck. Hope this helps. Good luck tomorrow. Talk to you later.